Hello everyone, today we are going to start a new subject, that is predictive analytics in the year 4th of R18 syllabus. In unit 1 we have linear methods for regression and classification, overview of supervised learning, linear regression models and least squares, multiple regression, multiple outputs, subset selection, ridge regression, lasso regression, linear discriminant analysis, logistic regression, perspective on learning algorithm. So in this video, up to linear regression models and least squares is covered. In the next videos, we will complete these all the rest of topics. Okay. What is predictive analytics? The subject itself name has predictive analytics. Then what is predictive analytics? The basic goal of predictive analytics is to forecast what will happen in the future. So this subject is mainly based on predicting the future values. That means forecasting what will happen in the future. Predictive analytics is a branch of advanced analytics that makes predictions about future outcomes using historical data combined with statistical modeling, data mining techniques and machine learning. It means that it uses the three statistical modeling, data mining techniques and machine learning, these three subjects to overcome and to forecast what will happen in the future. By using historical data, not the present data, it uses the past data combined with statistical modeling, data mining techniques and machine learning. Okay. First topic in this subject is overview of supervised learning. Don't feel that it has many slides. In the heading itself, it is asking about overview of supervised learning. So to complete this all the overview, it has been lengthy, but if you understand, it will be easy. Okay. Supervised learning is a machine learning technique. First, remember that I have told in the previous slide that it uses the statistical modeling, data mining techniques and machine learning. So first, supervised learning is the machine learning technique. Supervised learning is machine learning technique that is widely used in various fields. This is used in various fields such as finance, healthcare, marketing and many more. How it is used we'll be seeing in the next slides. Okay. It is a form of machine learning in which the algorithm is trained on labeled data to make predictions or decisions based on the data inputs. See one thing, in this supervised learning we will train the algorithm on labeled data. For what? To make predictions or decisions. It makes predictions or decisions mainly based on data inputs only. It considers only inputs. After considering inputs, after our training to our algorithm, it provides the output. Okay. So firstly, we will train the algorithm on trained labeled data set. Okay. And next, in supervised learning, the algorithms learns a mapping between the input and output data. Firstly, remember, supervised learning has both input and output data, but it mainly focuses on first input data only. Based on the input data only, we will get the output data, that is future values. This input is past data. Okay. In supervised learning, the algorithm learns a mapping between the input and output data. This mapping is learned from a labeled data set, which consists of pairs of input and output data. The algorithm tries to learn the relationship between the input and output data so that it can make accurate predictions on new or unseen data. As we said that we are training the algorithm on labeled data. That labeled data consists of only input data. It does not consist of output data. And at last, after we are getting an input and output, it makes a relationship between both the input and output data to see the unseen data on predictions. Okay. To understand better, see this diagram. Firstly, I told that we have input and output both. But for input, we uses the algorithm to train on labeled data. Labeled data in the sense we already know what is there in the labeled data. On that labeled data, by using algorithm, we'll train. And in output, what will happen in output? In input stage, we are using algorithm to train. But to test we are using the logic. Here I said that statistical modeling and data mining or machine learning techniques will be used. So by suitable algorithm will train the data in the input side, whereas for testing we'll use some logic, statistical modeling logics to predict the output. Okay, next, supervised learning is where the model is trained on labeled data set. It doesn't train on unlabeled data. It is trained only on labeled data set. A labeled data set is one that has both input and output parameters. In this type of learning, both training and validation is done. That means when we are training the algorithm, we also check that whether the data is valid or not, it is correct or not. Validation is also done by selecting the labeled data set. Okay, the labeled data set used in supervised learning consists of input features and corresponding output labels also. The input features are the attributes or characteristics of the data are used to make predictions. That means we are predicting a value for future. So the data that are used to make predictions by using the input features, while the output labels are the desired outcomes or targets that the algorithms try to predict. That means input features are the attributes or characters, whereas output features will desire outcomes or targets that the algorithms try to predict by using input. మీకు కరెక్ట్గా చెప్పాలంటే ఇక్కడ ఏం చేస్తుందంటే ఈ ఇన్పుట్ ఫీచర్స్ అనేటివి అట్రిబ్యూట్స్ ఆర్ క్యారెక్టర్స్ది ఒక డేటాని తీసుకుంటుంది. అది తీసుకోవడం వల్ల అది ఏం చేస్తుంది, ప్రెడిక్ట్ చేయడానికి ట్రై చేస్తుంది. అట్లా ప్రెడిక్ట్ చేస్తున్న టైంలో ఈ అవుట్పుట్ లేబుల్స్ అనేటివి ఏమవుతాయి, మనకి డిజైర్ అవుట్కమ్స్ ఆర్ టార్గెట్ అవుతుంది. ఎప్పుడైనా సరే ఈ సూపర్వైజ్డ్ లెర్నింగ్ ఫస్ట్ ఒక లేబుల్డ్ డేటా సెట్ తీసుకొని ఆ ఒక ఆల్గరిథంని మనం ట్రైన్ చేస్తామన్నమాట. మనకు ఫ్యూచర్ ప్రెడిక్షన్స్ కావాలి అని చెప్పేది ఈ ఫస్ట్ ఇన్పుట్ ట్రైనింగ్ డేటాలో అయిపోతుంది. నెక్స్ట్ ఈ టెస్టింగ్ దాంట్లో ఏమవుతుంది అంటే ఒక లాజిక్ తీసుకొని ఏదైతే మనం ఇచ్చిన లేబుల్ డేటా నుండి మనకి అవుట్పుట్స్ అనేటివి వస్తాయి అన్నమాట. ఓకే, నెక్స్ట్ సి హియర్ వీ హ్యావ్ టూ ఎగ్జాంపుల్స్. ఫస్ట్ ఎగ్జాంపుల్ is classification and second example is regression. In supervised learning we have two types. First one is a classification and second one is a regression. Remember these two examples, we'll see in the next slide. In figure A, what do we have? Figure A, classification. About what? User ID, gender, age, salary, purchased. It is a data set of a shopping store. This figure A is a data set of shopping store that is useful in predicting whether a customer will purchase a particular product under consideration or not based on his or her gender, age and salary. That means that based on a person's interest, based on the person's gender, based on the person's age, whether he will purchase that particular product or not. This is the figure A. Okay, so what are the inputs of figure A? Gender, age and salary. These three are the inputs of the figure A. Then what will be get output? Purchased, that is 0 or 1. That means we have two values only, binary values, 0 or either 1. 1 means yes, the customer will purchase, and 0 means that the customer won't purchase it. See, by seeing this figure, first user, his user ID, gender is male, age is 19 and salary is 19,000. So he purchased 0. That means it doesn't purchase that particular product. Okay, the next person has purchased. We said that 0 means not purchased, 1 means he has purchased. So these are the predictions based on what? Gender, age and salary. These three are the inputs, and what are the outputs we have got? Whether he will buy or not buy. So if we buy, we'll keep 1. If he doesn't buy, we'll keep 0 there. Okay, this is the classification. Then what is figure B? It is a metrological data set that serves the purpose of predicting wind speed based on the different parameters. That means that it predicts the wind speed based on different parameters. What are the inputs in wind speed? Dew point, temperature, pressure, relative humidity, wind direction. Based on these all the inputs, what are the speed of the wind will find. Okay, see here, temperature, pressure, relative humidity, wind direction. So based on these all the inputs, we can predict that what is the speed of a wind in a particular day or particular time. We can predict. So predicting is the sense is known as regression, whereas classifying means binary, whether he will buy or not buy. We have two conditions. These two conditions is called as classification, whereas original value and what is the speed for a particular region or particular area is called as regression. Okay, these are the examples. And we have types of supervised learning algorithm. We have two types. I said that classification and regression are the two types of supervised learning. Okay, here in classification defined labels will be there. In regression there is no labels defined. What is regression? Regression is a supervised learning technique. It means it is a learning technique used to predict continuous numerical values based on the input features. Means it predicts the continuous numerical values only based on input features. It does not see the outputs, it only sees the input features. Okay, it aims to establish a functional relationship between independent variables and dependent variables. It aims to establish a functional relationship between independent and the dependent, such as predicting house prices based on the features like size, bedrooms and location. See, for example, the last three, size, bedrooms and location. Based on these three, we can estimate the price of a house, how many centimeters or diameters or length, and where it is the location and how many bedrooms, and based on these all we can estimate the price of a house. So this is how we'll estimate. Then the goal is to minimize the difference between predicted and actual values using algorithms like linear regression, decision trees or neural networks. See, while we are predicting the size and bedrooms and locations of a house, we may correct sometimes and sometimes we may not correct by estimating that values. We may fail sometimes. So how we can find that error? We can estimate the values in the way where we can be exactly correct, or sometimes we are nearest to that. So for that, the goal is to minimize the difference, means to find the error. We are using the algorithms like linear regression, decision trees or neural networks. Okay, classification. We have learnt about regression and now we are learning about classification. What is classification? Classification is a type of supervised learning that categorized input data into predefined labels. Means it converts the data into predefined labels. That means already happened issues. Okay, it involves training a model on labeled examples to learn patterns between input features and output classes. Means it establish a relationship between the input and the output values. Okay, in classification the target variable is a categorical value. For example, classifying emails as a spam or not. See one thing, predefined in the sense we already have the data. We have all the mails in our phone. Okay, we have all the mails. In that mails we can easily classify what are the spam mails and what are the exact mails, and what are useful and what are not useful. We can easily estimate, right? So these are the things we can classify easily. It means in classification we have predefined labels and we can easily classify. Whereas in regression we have numerical value based on input features only. Based on input features we'll do. But here we already have the data, we already have the input. but for that input data we should do the output. Means we are just classifying, we are just using binary values, either yes or either no or 0 or 1, like that. We are giving a choice between or. Okay, so but here we will give an exact numerical value for based on input features. Okay, next, linear regression models and least squares. We said that for to control the error we are using some models like linear regression and least square methods, etc. For the linear regression we have only one independent variable or independent variable. If we have more than one independent variable and more than one dependent variables, then we'll call it as multiple regression. Okay, linear regression models and least squares. Linear regression is the simplest form of machine learning. By using linear regression, we can easily find the errors or what are the dependent variables and what are the independent variables. Okay, in statistics, linear regression is a linear approach to modeling the relationship between dependent variable and one or more independent variables. In the case of one independent variable, it is called simple linear regression. For more than one independent variable, the process is called multiple linear regression. Okay, let x be the independent variable. Okay, and y be the dependent variable. We will define a linear relationship between these two variables as follows. Okay, we'll use one formula, that is y is equals to mx plus c. We already learned this formula in our school standards. So see one thing. This is the equation for a line that you studied in high school. Okay, m is the slope of the line and c is the y-intercept. Today we will use this equation to train our model. We have said that we should train our algorithm. Okay, here how we'll train? With a given data set and predict the value of y for any given value of x. X is the dependent variable and y is the independent variable. Okay, our challenge today is to determine the value of m and c. We know x and y, but our challenge is to determine the value of m and c. Okay, that gives the minimum error for the given data set. We will be doing this by using the least squares method. Okay, first we should do finding the error. So to minimize the error, we need a way to calculate the error in the first place. A loss function in machine learning is simply a measure how different the predicted value is from the actual value. Okay, we are using a loss function to predict the actual value from to find the differences between the predicted value and the actual value. Okay, today we will be using the quadratic loss function to calculate the loss or error in our model. It can be defined as L of x is equals to summation I is equals to 1 of n, that is yi minus pi square. Why we are using the square? To reject the values in the negative. If we get any negative values, we are rejecting that. Okay, we are squaring it because for the points below the regression line y minus p will be negative and we don't want negative values in our total error. Don't worry, by seeing the image we can understand this formula at last. Okay, least square method. First we should learn what is least square method. Now that we have determined the loss function, the only thing left to do is minimize it. I actually told that we'll get an errors. So to minimize that errors, we are using least square method. Okay, this is done by finding the partial derivative of L. Okay, in this slide, L is there. No, we should partially derivate this L so that we'll get the loss function, equating it to 0 and then finding an expression of m and c. After we do the math, we are left with this equation. After squaring and after partial derivating the L, we will get this value, that is m is equals to, we will get this m and c values both. Okay, with these formulas I will explain example in the next video. Don't worry, this subject is mainly based on this least square method linear regression only. We'll also get multiple regression also. In that case, I'll explain you clearly. Okay, don't worry. Here x is the mean of all the values in the input x. Okay, and y is the mean of all the values in the desired output y. This is the least square method. Here xi means mean of the all values in the x, and here yi means desired mean of all the values in the desired output of y. Okay, see here diagram. In this diagram we have a red line. Okay, and these all are the predicted values. Green dots all are the predicted values. This is the red line. So for this red line we should find y is equals to mx plus c. Means we should find minimize the error. We should minimize the error for this red line. So after minimizing we should get the line like this straight. Okay, here y is equals to mx plus c we are using for this red line. After using that we'll get a straight red line, and above the line is the predicted values, and at p is the actual values. So y minus p means predicted values minus actual values will be done. This is the formula of for the predicted values and the actual values. Okay, don't worry, this is just explanation of what is what. In the next video we'll try to calculate all these values and all these formula by using one example. Okay, thank you.